I'm going to show you how to find the number of significant figures in a number. These 4 rules will tell us how many significant figures there are in a number. I'm going to post numbers here on the bottom and then just follow the rule and use the rules to count the number of significant figures. The first number I have here is 500. Rule number 1 says the farthest left non-zero number is the most significant figure. When it says most significant figure, it just means the digit that represents the largest number that is also a significant figure. Here I can see that the 5 is the farthest left digit that is non-zero. That means that it's the most significant figure, and therefore it's also a significant figure. So I'm going to mark it with this symbol. The blue dot means it's the most significant figure, and the red dot just means that it is also a significant figure. Rule 2 says if there is no decimal point, the farthest right non-zero digit is the least significant figure. And I can see that I do not have a decimal point, so this rule does apply. So if the other two numbers are both zeros, the farthest right non-zero digit is actually also 5, so that number is also the least significant figure. Rule number 3 says if there is a decimal point, the farthest right number is the least significant figure, even if it is a 0. That would apply if we had a decimal point, but we don't, so we're going to skip that rule. And all numbers between the most significant figure and the least significant figure are also significant figures. And again, this rule would apply, but there are no numbers between the most and least significant figure, because that's actually the same number. So we followed all 4 rules, and I can see that there's only one number that actually is labeled as a significant figure, so that 5 is the only significant figure in the number. So there's only one significant figure in the number 500. I'm now going to do the same thing, but this time the 500 has a decimal point. Following rule number 1, the farthest left non-zero number is the most significant figure, so that means the 5 is the most significant figure again. This rule applies if there is no decimal point, but here we do have a decimal point, so I'll skip that rule. If there is a decimal point, the farthest right number is the least significant figure, even if it is a 0. So here, because I do have a decimal point, the farthest right 0 is the least significant figure. And all numbers between the most significant and least significant figure are also significant figures. So I have one number between those other two numbers, so that is going to be my other significant figure. So now this number has 3 significant figures instead of 1. So that decimal changed which numbers count as significant. We have a much longer number here. Again, I'll just follow those steps. The farthest left non-zero number is the most significant figure, so that's 7 here. If there's no decimal point, the farthest right non-zero digit is the least significant figure. This rule applies because there's no decimal point. So I'm going to go as far right as I can without just hitting a 0. And that's going to be this 2 right here. The only other number after that is a 0, so we ignore that. So this is the farthest right non-zero digit, so that is the least significant figure. This rule applies if there is a decimal point, but there is not, so we ignore it. All numbers between the most significant and least significant figure are also significant figures, so every one of these other numbers is also significant, even the zeros, because they're all between the most and least significant figure. So here I can see there are 6 significant figures in this number. Here's another number, 80.040. Again, the largest left non-zero number is the most significant figure, so that's going to be this 8. This rule applies if there's no decimal point, but here there is a decimal point, so I'll skip it. If there is a decimal point, the farthest right number is the least significant figure, even if it is a 0. So the farthest right number is over here, and it's a 0, but that's okay because the rule says it's okay, so that is the least significant figure. And all numbers between the most and least significant figures are also significant figures, so all of these numbers are also significant, so this number has 5 significant figures. Here's another one. The farthest left non-zero number is the most significant figure, so here that's going to be this 4. All the numbers to the left of it are 0, so they don't count. So that's the most significant figure. This rule only applies if there's no decimal point, and here there is. Rule number 3 says the farthest right number is the least significant figure, even if it is a 0, as long as we have a decimal point. So this 0 over here is the farthest right, so that is the least significant figure. And all the numbers in between those two are also significant figures. So there are 4 significant figures in this number. For numbers in scientific notation, only count numbers in the coefficient as significant. The power of 10 does not add to the significant figures. So here in scientific notation, I can see that this is the farthest left non-zero number, so that's the most significant. This rule doesn't apply. This rule says the farthest right digit is the least significant figure, so that's going to be this 8. And all the digits in between are also significant figures. So the power of 10 does not contribute to the number of significant figures. So here the number of significant figures is 3. That's how you apply those rules to find the number of significant figures in a number.